Okay, this is Andrew. In the last video, we left off with a collision domain and the problems that caused by collision, that it corrupts the data. So a solution is carrier sense multiple access with collision detection. And we started to discuss this. Like I said, I didn't read these to you, but you're free to read those. There's going to be, at this level, there's going to be many different description of what exactly is CSMA with CD, but I like this description, so we're going to go with that. So, okay, where we left off with the hub is one broadcast domain and one collision domain. So the first thing with the CSMA CD is if this PC right here wants to transmit, send a message to any other PC, he's going to look to see if someone else is on the line, okay? So how does he do that? He just samples the voltage, okay? If there's no voltage, well, in reality, it probably won't be 0 voltage, but we're just going to use 0 and 5 volts for simplicity here. So he samples the line, and there's 0 voltage. Okay, so he could have transmitted at that time. But if there is a transmission online, hold off. Okay, so this PC is transmitting. So this PC wants to transmit. So he senses this line, and now remember, this is a hub. This 5 volts is going to be everywhere. It's not just here. It's on this plate. It's on these lines. It's on this line. It's on his NIC card. So he measures that on the NIC card, and he says, oh, there's 5 volts. Somebody's already talking. So he just holds off. He has to wait. He senses 5 volts. He has to wait. He stops. This guy's green. He goes. Okay, when this guy stops, then he's free to transmit. So he says, okay, clear to transmit. So he starts to transmit his 5 volts. Oh, that's great, okay. And as he transmits this, if his transmission is uncorrupted, that means he never detected any other voltage on the line, then assume no collision and that the data transmission was good. But what if, as soon as this guy stopped transmitting, this guy was waiting too, and this guy was waiting, and they both happened to transmit at the same time? If they happen to transmit at the same time, then you're going to get a collision. Bam. So what do? You check to see if the line is, if the data is corrupted. If it's corrupted by seeing this 10 volts, then you know that a collision occurred. So at that point, once you know you have a collision, then everybody backs off. Everybody just shuts down, quits transmitting, and waits a random amount of time and starts over. So the idea is that this guy would wait, for a number of microseconds or milliseconds, and this guy would wait a number of milliseconds, and they're all different. So one of them's going to start transmitting again, and when the other one hears that he's transmitting, then he's going to wait till he's done. So that's the way collision domain CSMA CD worked, and it worked well for a number of years, but you can see the problem with it. If you've got 50, 100, or even more PCs on a line, then the problem with that is there's going to be a lot of collisions, and that's going to slow down your data transmission. So in comes the switch. Okay, the switch actually is smart enough and fast enough such that if PC1 takes data and wants to send it somewhere, he can go ahead and send it at the same time PC2 here is doing it. So they're actually independent. So even though everything is in one broadcast domain, this setup here has 5 collision domains. Each one of these ports on this switch is its own collision domain. So that's where the switch comes in, and there is no CSMA/CD with this. But what there is the way the switch works, and the switch is going to work like this. It forwards, floods, or filters data, okay? based on the MAC address. So let's say A wants to send a frame to E. Okay, so A is going to send a message, a frame to the switch, and there's what's called a MAC table. And the first thing the switch is going to do when he gets that message is he's going to look at the source. A frame has a MAC source address and a destination MAC address. So let's just say it's all A's for this PC, all B's for this PC, all C for this. This is the MAC address, all D's and all E's. That may not be a real MAC address, but to make it simple, that's what we're doing for now. So the message comes into the switch, okay, and the switch says, "Oh, I don't know the MAC address A. I don't know that, but I do know that the thing connected out here with the MAC address A is on my port 1, my switch port 1. So he adds the he adds the port number 1 and the MAC address to the MAC table. So now he knows from this point forward that A is on port 1. Okay, so this frame is going to E. Okay, so the destination is E. Well, what MAC address, what port is assigned to the MAC address all E's? He doesn't know. So all he can do is flood out the broadcast domain. So the switch sends the message everywhere to all computers that are in this broadcast domain. Okay, that's good. That's causing a lot of data. I mean, you can imagine if there's hundreds of computers and they're coming in here and here and here and here. Well, maybe not hundreds, but let's say a large number of computers, and they're all transmitting data to everywhere at the same time. There's going to be a lot of data, and that's really going to slow you down. So what happens at this point is after the flooding, B says, well, that data is not for me. I don't need it. And C says, that data is not for me. And D says, that data is. But E says, oh, that is for me, and I'm going to respond to that message. So E sends a frame that's destined back to A. So A is the destination, and E is the source MAC address. So the E comes into the MAC table, and the switch says, oh, yes, here's a new one. Here's E. And he's on port 5, so he assigns port 5 to the MAC address E. And now he knows, so he knows where A is. A is out port 1, so he forwards. He doesn't have to flood out every port anymore. So he forwards directly up to A. So as the switch begins to learn, the switch starts to learn which ports and which MAC addresses are attached to each port, and it assigns that to its table, and from that table it begins to send data from one source host to a destination host only by forwarding the data. So we can see how it's building the table and forwarding the data, and that's a huge improvement from the days of hubs. Okay, thank you very much. I hope that was pretty clear. Thanks.